Assalamualaikum. My group will talk about geothermal power generation. My name is Nur Muhammad Furqan. I will talk about introduction. The word geothermal comes from the Greek where geo means earth and thermal means heat. The heat that exists within the earth is known as geothermal energy. Heat at a depth of 1000 meters below the surface of the earth has 50,000 more energy than oil and gas at the earth's surface. This makes the cost of using geothermal power generators expensive. The geothermal power generation uses renewable energy and is safe for the environment compared to fossil fuels. Geothermal power generation uses a high heat source where the temperature is between 300 to 700 degrees Celsius. To get this heat source, we must drill below the Earth's surface, then the heat is transferred to the Earth's surface by using pipes. There are several heat-producing layers of rock, minerals and magma beneath the Earth's surface, including the mantle, the outer core and the inner core. The most common type of geothermal energy generators are dry steam, lightning steam and binary cycle. The less fluid that needs to flow from the ground to take advantage of a hot resource, the more useful it is. Next, basic principle. The meaning of the basic principle can be separated as basic and principle. The basic is easily described as a thing or process to follow the flow of the process, while the principle is to mean as the law of philosophy in which the process needs to follow the requirement of the process. This assignment is more about geothermal power generation, known as the natural source, which is heat. The geothermal power generation is called a power plant, and under the power plant there are three types known as flash steam, dry steam, and binary cycle. This section will explain the basic principle of the geothermal power plant and the three processes under the type of power plant. This process is where the source is collected from the underground to produce electricity and make the operation. They need to drill the hole and insert the pipeline until it reaches the underground resources where heat products such as volcanic area and steam hot water only in the underground. Below are the description of the operation or basic principle of the geothermal power plant.
Assalamualaikum. My name is Muhammad Nazmi. For the operation and basic principle, the first step is from the underground, the hot water will pump to the surface through the pipeline using high pressure. Next, when the hot water reaches the surface area, the water pressure will drop. Thus, the hot water will change to steam. The third operation is that steam produced will go through part 3, the turbine connected to the generator. The shape of the turbine is like the fan, and the steam that passes through away the turbine will spin the fan blade. The spin of the turbine connected to the generator will produce the electricity we need. The next step based on the figure above is the cooling tower. This area is to conduct the steam water from the generator to be cooled down. When the steam water cools down, the water will change into condenser water. Lastly, the water condenser will pump back through the injection well underground. Furthermore, the process can be repeated as the geothermal power generation is natural resources. Type under geothermal power plant. There are three types of geothermal power plants, which are the flash steam power plant, dry steam power plant, and binary cycle power plant. This section will also explain the operation of three types of geothermal power generation. The difference between dry steam and flash steam is that the source from underground is produced using high pressure, and the hot water underground will be converted into steam, while the dry steam is collected from the original steam itself. This type is more used in geothermal power plant operation. Operation and basic principle. From the figure, the hot water from underground was pulled up to the surface directly to the flash tank. Next, the hot water will be converted into steam and make the steam pass through the turbine. The steam will make the turbine spin and transfer the movement to the generator. The generator will produce the electricity based on the spin of the turbine. Lastly, the water will be condensed and drawn back to the underground pipe. A dry steam operation is where the heat is pumped up from the underground resources called steam. The steam from below will generate the turbine and generator, thus the producing electricity, and most of the steam is collected from the geothermal reservoir. And basic principle. The steam is collected from the underground geothermal reservoir directly pump up the turbine. The steam pass through the turbine and makes the turbine blade spin, and the generator connected produce electricity. Lastly, the steam condenses will flow back to the injection well underground. This type of power plant transfers the heat from the ground into hot water to another liquid, and the next liquid will turn into steam and pass through the turbine. The call binary as the two working become mutual finish. And basic principle. The heat from underground pumps up into the heat exchanger. The heat exchanger makes the heat from the ground turn from hot water to another liquid. The liquid from the next pipe will change into steam and pass through the turbine. The steam flow will spin the turbine blade and generate the generator to produce electricity. Lastly, the process water withdraw to the injection well in pipe 1 in the heat exchanger. The process can be repeated.
We move to basic construction or material. First, the generator, steam turbine, cooling tower, condenser, hydrogen sulfide abatement system and gas remover are the essential components of a geothermal power plant, while transport geothermal energy in the form of pressurized steam to the power plant via pipe. At a pressure of 40 to 100 pounds per square inch, steam is pumped into the turbine. As steam expands and through the turbine, thermal energy is converted to hydraulic rotational energy. The steam turbine is immediately connected to the generator, which converts mechanical power into electrical power. In geothermal energy, there are three requirements to be considered to generate electricity, which are: first is fluid. A specific amount of fluid should exist in the crack and pores phase of the rock. Second is heat. The temperature of the rock must be higher. Heat is generated within the crust of the earth through radioactive elements. Due to the fact that the rock must be hot, they are cool and brittle in comparison to the more well-known magma or lava. Lastly is permeability. Crack and pore gap must allow fluid to contact the overheated rock. Magma is a geothermal energy material that heats the surrounding rock and basin underground. Because gases, vapor vent, mud pot and submerged thermal vent are all geothermal electricity sources, they can all spew hot water. They can store the heat or steam and use it to generate energy. In figure 6, it shows that the red arrow, which is steam and hot water, move upward to generate electricity.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazmi Iskandar. Today I will be presenting about the example of the actual power plant generation site, which is the first one that we get is Gunung Salak Geothermal Plant, Indonesia. Gunung Salak Geothermal Plant is in West Java, Indonesia, that has a 377 megawatt geothermal power capacity. The Union Oil Company and Chevron Global Energy developed this power plant together with other companies. Star Energy Consortium, which included electricity generating public company, Star Energy Geothermal, AC Energy, and Star Energy Group Holding, purchased the power plant project in December 2016. 180 megawatt of electricity was supplied to the geothermal steam generated from the power plant to a plant managed by the State Electricity Company (PLN). 197 megawatt of energy from geothermal steam was generated by the power plant and supplied to the Jawa Madura Bali system. The Gunung Salak geothermal project was upgrading three turbines from 55 megawatt to 60 megawatt to enhance its efficiency at an existing geothermal power plant which is in the Halimun Salak National Park. The plant can generate more energy from the same geothermal steam source when this 15 megawatt is increased in installed capacity. Indonesia will use the renewable energy, electricity to fulfill the expanding energy demand, thus decreasing the need for polluting fossil fuel power facilities. On the next slide, we will see the picture of the Salah geothermal plant in Indonesia, where we can see there is a steam that been released in the air after the turbine that has been turned, and then the steam will be let out to the atmosphere. All right. Next example that we got is at the United States of America, USA, which is the name is the Geyser Geothermal Complex. Okay, the Geyser Geothermal Complex is in the north of San Francisco, California. There is 45 square miles on the boundary between Sonoma and Lake counties, which make it the world's largest geothermal power generation. There are about 18 power plants that are operated at the geyser with a net generating capacity about 835 megawatt of electricity. In the mid of 1880s, the geyser complex operated as the geyser resort as a spa to attract visitors, but visitors eventually lost interest by the turn of the century. The resort owner built the first power plant at the site in 1921, which produced about 250 kilowatts and powered the resort lights. In 1987, the geyser reached a peak in steam production and electricity generation because of the increased steam output linked with quick and excessive development, followed by a large drop in reservoir pressure. To recharge producing well at the geyser, the Northern California Power Agency (NCPA) built the world's first wastewater geothermal injection system in 1997. To fulfill that, NCPA partnered with the Lake County Sanitation District to pump the treated wastewater effluent 26 miles down to the geothermal reservoir using two 1 megawatt solar array, which is significantly prolonging the life of this clean base load resource. The geysers have continued to create electrical power for almost 50 years. Um, the power plant have exceeded the expectation of many research, despite of a lot of challenge that the geyser geothermal complex have faced. And next, we will see on this slide that we have here is a picture of the geyser power plant in Francisco, which I have stated earlier. This is all the steam that have been blown out to the atmosphere after it's already been used uh, to spin all the turbines that is in the power plant. So that is all of my presentation. Thank you for listening and goodbye.